Good morning, students. In the previous class, we completed the third unit. Okay, the third unit, which was uh, which was discussed about the concept development, concept selection, and concept testing. Okay, now I am talking about the fourth unit, that is the product architecture. The product architecture plays a very important role in the product development. Then what do you mean by the product architecture? The product architecture is nothing but a systematic design and arrangement of all functional elements of the product or components of the product. Okay, how effectively we can design each and every component of the product, and how effectively we can design the components compactly, and how effectively we can reduce the number of components in the product. So like this, we need to decide the product architecture or the layout of all the functional elements and parts of the product. That is called as product architecture. So in this connection, I will give an example. Okay, the Hewlett Packard, the manufacturer of printing devices, they are facing a big challenge or the big issues to address the customers in the market, and also they are facing huge pressure from the market to increase the varieties of the printers. At the same time, they wanted to reduce the manufacturing cost of the varieties printers. Okay, as you know that they are into the development of black and white high quality inkjet printers. At the same time, they are involved in development of high quality the color inkjet printers. Okay, but there is a huge pressure from the market for them to design a product, to design varieties of inkjet printers. At the same time, they have to reduce the cost of manufacturing of these printers. Okay, and the price is being fixed by the market. Okay, the earlier the price was going to be fixed by the manufacturers. Nowadays, the price of the product is going to be fixed by the customers in the market. That is nothing but market will decide the price for your product. Okay, so based on the decision, that price fixing is nothing but, so we have many competitors of the inkjet printer manufacturers, and they are also selling at the same market segment. Okay, we need to set our market price or the in comparison with the competitors in the market. That is nothing but they setting the price for the market. Okay, based on that, how well we can design all the components, okay, and manufacture with a low cost, but without any compromise in the quality of the printing equipments. These are all the challenges the Hewlett Packard is facing in the market. So with these challenges, the team of the product development have been asked these questions themselves. How would the architecture of the product impact the ability to offer the product varieties in the market? The second challenge, what would be the cost implications of the different product architectures? Okay, the cost definitely varies from one architecture to the other architecture. Then what are those cost implications? And how would be the architecture of the product impact their ability to complete the design within the specified period of time? Okay, and also the market will decide the time for the introduction of their new varieties of the products of the inkjet printers to the market. Okay, the time is fixed. So are we able to meet these varieties of products designed, developed and manufacturing and giving it to the market? Then how would be the architecture of the product influence their ability to manage the development process? Okay, the decided architecture, would it support, okay, will it be feasible for our product development team or not? So these are all the sort of challenges being asked within the product development team in with respect to the product architecture for inkjet printers faced by the Hewlett Packard manufacturers. Okay. So then we need to adopt the product architecture procedure. So that we'll be discussing in this chapter. Okay. The product architecture is the assignment of functional elements of the product to the physical building blocks of the product. So that is nothing but the product consists of lot of functional elements. So these functional elements have to be fixed to the building blocks, or they are going to be assigned to the building blocks of the product. That is known as product architecture. And in this chapter, the purpose of the product architecture is to define the basic physical blocks of the product in terms of what they do and what their interfaces in the rest of the devices in the product. Okay, so the product architecture, it defines the development of building blocks, functional building blocks for the product. And the architectural decisions allow the detailed design and testing of these building blocks to the assigned teams, individuals and suppliers. Okay, and also this product architecture will also tells about the system level design, or it allows the design of all the functional elements and also testing of these functional elements of the product. Then what is the product architecture? Okay, so some other definitions. The product architecture can be thought of both functional and physical terms. Okay, it consists of both functional and physical terms. The functional elements of the product are the individual operations. The functional elements of the product are the individual operations and transformations that combine in the overall performance of the product. Okay, we come across two things with respect to the product architecture. One is the functional terms and another one is physical terms. The functional terms are nothing but the operations and transformations that contribute to the overall performance and functions of the product. Okay, that is called as functional elements. That is called as functional elements. For example, printer. Some of the functional elements are store paper and communicate to the host computer. Okay, these are all the functional elements of the printer. Okay, so then comes to the physical elements. The physical elements of the product are the parts, components and sub-assemblies that ultimately implement the product functions. Okay, I repeat once again, because you should know the difference between functional elements and physical elements, which creates the product architecture. Okay, the physical elements of the product are the parts, are the components, or the sub-assemblies. Okay, that implements the product functions. Okay, so this is what the clear distinction between the two things, that is functional elements and the physical elements of the product architecture. Okay. Then the physical elements become more defined as the development process progresses. Some of the physical elements are dictated by the product concept itself, at the beginning of the product concept itself. And the other product architecture, if it is completely new product, okay, that is going to be dictated as and when the product concept generation, evaluation progresses. Okay. Then physical element of the product are typically organized into several major building blocks. Okay. The physical elements, one is functional elements and the physical elements. Physical elements are nothing but they are the components, they are the parts, they are the sub-assemblies. Okay. So these physical elements of a product are typically organized into several major physical building blocks. They are assigned to physical building blocks. And these building blocks are called as chunks. Each building block is called a chunk. CHUNKS, chunk. Okay. Then the chunk is then made up of collection of components, okay, that implement the function of the product. Okay, what is the chunk? That is nothing but a building block. Is nothing but it is made up of collection of components. Chunk is collection of components. Okay, the chunk is nothing but a building block, a collection of components that implement the functions of the product. Okay, is it clear? Then the architecture of the product is the scheme. Architecture of the product is the scheme or the layout in which the functional elements of the product are arranged. The functional elements of the product are arranged into physical chunks, and by which chunks will interact. That is nothing but each building block will interact and they produce the required output for the product. Produce required output of the product. So each chunk is nothing but each building block have been assigned with certain functional elements, and these chunk will perform the functions and give the desired requirements of the product. Okay, so like this, the various chunks and building blocks with respect to the functional elements have to be embedded in that to perform the functions and to give the desired requirements from the product for the customers. So this systematic designing and arranging of all these building blocks is product architecture. For example, you refer figure 9.2, figure 9.2. So they have given two sketches there. The first sketch is meant for, okay, that is 9.2. As a bicycle manufacturer, they wanted to design chunks, okay, to perform certain functions. Okay, there are two functions are considered. One is known as the braking function, and second one is the shift control. Okay, so these two functions have to be performed by chunks or the building blocks or by the components with respect to the product. So the traditional design of this brake control and the shift control have to be placed separately on the bicycle, and they do functions independently, one after the other. That is a traditional design. That is the left hand side of the figure. The right hand side of the figure, if you look at it, if you look at that, so it is the integral chunk. Okay, the modern integrated chunk. So it combines the both shifting control and braking control in a single chunk or a single component. Okay, this is the advanced or the modern chunk. See how the traditional bicycle design functions have been improved over the years. Okay, the combined integrated chunks have been designed. Okay, so in this product architecture, one more important the product architecture term, that is called as the modularity. Okay, the modularity is the important characteristics of the product architecture. Okay, so we have two modular architectures. Okay, the one is known as modular architecture and second one is integral architecture. The modular architecture has got these properties. The chunks implements one or few functional elements of their entirety, and interaction between the chunks are well defined and are generally fundamental to the primary functions of the product. Okay, so then most of the modular architecture is one in which each function element of the product is implemented by exactly one physical chunk. Okay, as in case of the traditional bicycle shift control and the brake control functions. So they are independently being designed and they have been separately fixed. Okay, then if you consider the other modularity, that is called as integral architecture. So already I gave an example of integrated product. Okay, that combines the shift control as well as the brake control for the bicycle. Okay, so this has functional elements of the products are implemented using more than one chunk, and single chunk implements many functions. Okay, one chunk performs many functions, more than one function. So that is shift control as well as brake control. Both will be done by only one chunk. That is called an integrated approach. So like this, these are the two architectures, modular architecture and integrated architectures. Okay, we need to look at these things and we need to embed these concepts in our product design while deciding about the product architecture. Then one more important thing, the different types of modularity. Okay, there are three types of modularity. One is known as slot modular architecture. You refer figure 9.3. Slot modular architecture. And second one is bus modular architecture. And third one, sectional modular architecture. Okay, in the examination they ask what are the different types of architectures and what are the various types of modularity. Okay, there are three types of modularity. One is slot modular architecture and bus modular architecture and sectional modular architecture. Okay, so then we discuss about the slot modular architecture. Refer figure 9.3, the first figure. Okay, you look at that. Each of the interaction between the chunks in a slot modular architecture is one of the different type from the others, so that the various chunks in the product cannot be interchanged. Okay, the chunks cannot be interchanged in a slot modular architecture. Okay, keep it in mind. Here, the chunks are not possible to interchange, and each chunk is meant for to perform its own function. Okay, keep it in mind. Then the second one is bus modular architecture. The bus modular architecture, okay, there is a common bus on which the other chunks are connected via same type of interface. Okay, and common example for this is bus modular architecture would be the expansion card for the personal computers. It is the best example for bus architecture. Okay, it is something like a line. On that line, the slots are being provided, and each slot, each chunk is going to be fixed, and they interface with one another. That is called as the bus modular architecture. Then third one, sectional modular architecture. Here, all interfaces of the same type, but there is no single element to which all other chunks are attached. Okay, you can look at the figure. Okay, we can see how the sectional modular architecture is being designed and used to fix the chunk on the sections of the component. So these are the three types of modularity we need to consider, okay, while designing the product architecture. Then when the product architecture is being defined, okay, for example, if a small improvement in already the product existing, see, the most of the chunks and the building blocks of the product have been already defined. A small change, okay, the small change has to be considered in the beginning of the development phase itself. Okay, because we are making not whole change, we are not designing the whole new product, but already the product existing, already the functional elements are there, already the physical elements are there, slight variation in the functions because of the add-on features for the existing product. Okay, so already exists in the concept development phase itself. So when you are designing a new product, completely new product, assume that there will not be any existing products, completely product is very new. In this situation, okay, we have a lot of responsibility of the product design engineers with respect to the product architecture, because the product architecture is not so clear in the concept generation. The concept generation, we have rough sketches, rough models, rough 3D models, rapid prototyping models, something like that. Okay, the system level design and component design are in the preliminary stage, are in the component stage, where the product architecture plays a very crucial and important role about deciding about the functional elements and also deciding about the physical elements and the chunks and the modularity, whether the modularity architecture has to be adopted or the integrated architecture has to be adopted, or what type of slot modular architecture is to be adopted, or bus modular is to be adopted, or sectional modularity is to be adopted. So a lot of challenges are there when completely the product is new. Okay, so we need to decide whether we are designing a completely new product, and whether we have the existing products. The product architecture depends upon the type of the product we are into developing. Then the implications about the product architecture. Okay, the decision about how to divide the product into chunks and how the modularity to improve on the architecture. Okay, these are tightly linked to several issues of the enterprise. One is, okay, these are the implications, these are the challenges, these are the issues how to be addressed in the product architecture. So it depends upon the lot of activities of the functions of the organization. The first one is the product change. Second one is product variety. Third one is component standardization. Next, product performance, manufacturability, and the last one, product development management. So these are all the 7 to 8 issues how to be handled in developing the product architecture. Okay, for example, consider the first implication of the product architecture, that is product change. The chunks are the building blocks of the product, as we already discussed, but the architecture of the product defines how these building blocks relate to the functions of the product. That's all, we are aware of that. Therefore, how the product can be changed, with respect to the product architecture. The modular chunks allows change to made to few isolated functions of the product without necessarily affecting the design of other chunks. Okay, see the product change, as I gave an example already, if there is a small change in the product variety, so we need not design all the building blocks of the product. Okay, we need to change is to be expected in certain chunks or certain building blocks of the change, depending upon the change we are expecting in the existing product. So we must see that while designing modular architecture or the integrated architecture, and where these changes can be made. Okay, that is going to be seen. So the product change happens because of the following things. One is upgrading the existing product, and another one is add-on. Add-on is nothing but the manufacturer will supply a base product to a customers. The add-on, nothing but the additional accessory is going to be fixed on the product, and those components being supplied by the other suppliers in the market, not by the company manufacturer. The company manufacturers will just supply the main product. Then adoption. So depending upon the environment, the vehicle need to be adopted. And wear. Okay, the architecture should be take care that if the components are get weared out, they can be easily replaceable. And consumption and flexibility and reuse. These are all the things, okay, would help the product architecture with respect to the product change. Then product variety. Okay, already see that the chunks must be designed to take care of small modifications, small changes in the product variety. Okay, with a low cost, we can modify the existing design to meet the product variety with a low cost. Then component standardization. So the components which is being chunks are the components which are being designed in the product architecture. Okay, they are to be standardized such that the same component on the other varieties of the product which we have designed or developed, the same component has to be used even for the other variety of the product in the range. Okay, that is known as standardization. If each chunk or each component is being not standardized, each variety has got its own dimension, and it is very difficult to get the components in the market. So if the standardized components are available, So we can use for varieties of products in the market. So that's why the standardization also plays a very important role. Then comes to the product performance. Okay, the product performance. Okay, there is integrated performance, for example, efficiency, thermal efficiency, the speed and the noise. These some of the combined functions will define the product performance. Okay, so how to design the integrated, how the integrated design, the integrated architecture should support the performance improvement of the product is also taken into consider. Okay, in product architecture. Okay, in the book they have given two examples. One is the basic motorcycle which is being designed and how the components or the chunks have been attached to the frame and to the structure. And similarly the new advanced motorbikes, something like a race bikes, okay, how the component integrated design, integrated architecture has been used. You just refer the figure 9.5 and understand. Then come to the manufacturability. See, the product architecture also tells that how best we can reduce the cost of manufacturing. Okay, that is called as manufacturability. Okay, with a less variety. Okay, it also supports the standardization and the product variety. Okay, so how best we can manufacture the product with the least cost. So that is called as the manufacturability. So that depends upon the architecture or the chunks which we design in the product architecture. And also the last function is product development management. Okay, how the system level designing is to be managed by the various teams or by the individual people or the various teams. So the modularity is going to be done. Each chunk is to be given to a small group of team of people or as individual and the complex chunk has to be given for the intellectual teams. So like something like that, the modularity or the whole building block of the product structure has to be split and is going to be given to the 8 individual groups, and they have been authorized for the development of the size, shape, and using all the modularity concepts in the designing and come up with a low cost product architecture components are the building blocks for the final product. So the next class I will be taking about the steps involved in product architecture. Okay, and also in the next class I am going to give you some kind of questions related to this product architecture chapter, that is 4th unit in your syllabus. Yes, all the best. And again, you know that this has been extended. The lockdown has been extended to 3rd May. So by the time I'm going to sure that I'll complete all the portions. Okay, you be prepared. Understand? Okay, bye.